Hi, welcome to Zona Mechanica. There is an MCQ on slenderness ratio of column. Figure at the margin indicates the weightage of the question, that is 1 mark. A column has a rectangular cross section of 10 mm by 20 mm and a length of 1 meter. The slenderness ratio of the column is close to 200, 346, 477, 1000. Well, this is a tricky question. There are few key points which you must know clearly to answer the question correctly, like what is slenderness ratio and what is radius of gyration and the variation of radius of gyration on the cross section of the column. Okay, you must know all these things to answer the question correctly. First of all, slenderness ratio. It is the ratio of equivalent length of the column to the least radius of gyration. Least radius of gyration. Okay, that is LE by K. Okay, now what is radius of gyration? See, radius of gyration is the maximum deviation of the axis of the column from the mean position. It varies with the cross section of the column. Let us consider these three columns of circular cross section, square cross section and a rectangular cross section. If some buckling load is applied to the column, then the column will buckle in its weakest direction. Okay, since this is a circular cross section, that is the column is cylindrical and the material is homogeneous, so all the directions are equally strong from the axis of the column. In all the directions the column is equally strong, so it may buckle in any direction. Okay, it may buckle in any direction. So suppose it is buckling in this way, so the maximum deviation of the axis from the mean position is the radius of gyration. Okay, so for circular cross section it is having a single radius of gyration. For circular cross section it is having single radius of gyration. And for the square cross section it may buckle in two directions, either in this direction, okay, or in this direction. So in either direction it buckles, the radius of gyration will be same because these two sides are equal, right? So in either direction it buckles, the radius of gyration will be same. But in case of rectangular cross section, see, it may buckle in two directions, either in this direction or in this direction, right? In this case, since these two sides are not equal, so the radius of gyrations will be different in two cases. If the column buckles in this direction or in this direction, K1 and K2 be the two radii of gyrations. Okay, so what is the expression for radius of gyration? See, we have a relation with moment of inertia. That moment of inertia I is equal to A into K square, where A is the cross sectional area. Okay, so if we draw here the cross section, okay, suppose this is my major axis and this is my minor axis. Okay, I'm saying this longer side is major axis side and this shorter side is minor axis side. Let this is B, this longer side, and shorter side be D. Okay, so the moment of inertia, if we consider this longer side, if we consider the radius of gyration along the major axis, then the moment of inertia I will be B d cube by 12. Okay, suppose this is I1, and if we consider the moment of inertia while the column buckles in shorter side or minor axis side, in that case moment of inertia I2 will be dB cube by 12. Okay, so the K1 will be root over of I by A. Okay, K will be root over of I by A. So K1 will be root over of B d cube by 12 into B into D, right? That is root over of D square by 12, and K2 will be root over of dB cube by 12 into BD, right? That is root over of B square by 12. Okay, so clearly if D is greater than B, K1 will be higher than K2, and if B is greater than D, then K2 will be greater than K1, and K1 will be least radius of gyration. So in our case, we have considered B as the longer side, so K1 will be the least radius of gyration. So it will be equal to D is equal to, in our case, 10 mm and B is 20 mm, right? So root over of 10 square by 12. So that is equal to 2.887. Okay, so we have to take the least radius of gyration in the calculation of slenderness ratio. So therefore slenderness ratio will be equivalent length is 1 meter, that is 1000 millimeter, by least radius of gyration, that is K1 2.887, so which is equal to 346. Clearly it's matching with option B, so option B is the correct answer. Hope you have understood. If you are enjoying, please do share with your friends.